In this video, we're going to go over quiz 2.1 from Unit 2 on graphing quadratics and forms of quadratics. So the first question was f of x equals negative 2, x minus 1, x minus 5. So this is an equation that's in factored or intercept form. So when it's in factored form, what factored form gives us is our x-intercepts. And we get it by doing the opposite. So if it's x minus 1, it's x equals positive 1. And if it's x minus 5, it's x equals 5. So my two x-intercepts are going to be 1 and 5. So if I plot those, I need to find the midpoint because the midpoint between my x-intercepts is going to be where my axis of symmetry and the x of my vertex is. So my midpoint would be right here at x equals 3. So 3 is the x of my vertex. Then what I can do is I can take that 3 and plug it back into the original equation. And I'll get 8. So my vertex is at 3, 8. Now I'm going to graph my equation. So I need to use my pattern, 1, 1, 2, 4, 3, 9. But my a value is negative 2. So I'm going to multiply all these by negative 2. So I'm going to go right 1 down 2 on both sides. Right 2 down 8 is where my x-intercepts were. And I will actually be able to fit 3, 18. So if you wanted to plot those, you could. By plotting the 3, 18, we can actually see where the y-intercept is. And the y-intercept is at 0, negative 10. If you didn't plot that last point, remember that you could always plug in 0 for x into the original equation. So I could have done negative 2 times 0 minus 1 times 0 minus 5. And I would have got negative 2 times negative 1 times negative 5, and that would have given me negative 10. So that's another way you can solve for the y-intercept. Our second equation was in standard form. When we have an equation in standard form, we're going to use our little formula opposite b over 2a. This is going to help us find the x of symmetry as well as the x of the vertex. So when I do that for this equation, it's going to be opposite of negative 2 over 2 times negative a half. So I'm going to have positive 2 over negative 1, which will give me an x of symmetry of negative 2 and an x of my vertex of negative 2. Now I can take that negative 2 and plug it back into my original equation to solve for the y of the vertex. So that would give me 4 times negative 2, or negative half would be negative 2. So it's going to be negative 2, 10 is going to be my vertex. All the way at the tippy top here. All right, then I want to use my pattern. So 1, 1, 2, 4, 3, 9. But the a value is negative 1/2. So I got to multiply that by negative a half. I could have also done 4, 9, which if I multiply by negative a half would be negative 8. So using the new pattern, I'm going to go right 1 down a half, right 2 down 2, same on the left. Right 3 down 4.5. And then I can go right 4 down 8. We don't need all these points. If you wanted to just plot the ones that were whole numbers, that would be fine too. And on my graph, I can see that my y-intercept is at 0, 8. If you remember, if you plug in 0 into a standard form equation, your y-intercept is always going to be your c value when you have an equation that's in standard form. Our last equation was in vertex form. And this form involves the least amount of computation because we know the minus 4 means right 4 and the minus 6 means down 6. So we're going to go right 4, down 6, and that's where my vertex is going to be, at 4, negative 6. And so we know that the x of symmetry is always the same as the x of the vertex. Then I'm going to use my pattern, and I have to multiply it by 2 because my a value is 2, which I can see right here. And then plot my pattern. I won't be able to fit 318, but that's okay. On this graph, we don't see the y-intercept. So if I want to solve for the y-intercept, I'm going to plug in 0 for x. So 0 minus 4 squared minus 6 is going to be 2 times negative 4 squared. 2 times 16 minus 6, that'd be 32 minus 6, which would be 26. So my y-intercept is 0, 26. And this top question says, is there a maximum or a minimum? And this kind of relates back to our functions unit. Since my parabola has a low point or is facing upward, this graph would have a minimum. On the back were two graphs of graphing quadratic inequalities. So when we graph these, we graph them the same way we're going to graph parabolas. We just have to remember a couple extra things about our type of line and where we shade. So this first equation's in vertex form, so I know that this is right 3 up 7. So right 3 up 7. Then I'm going to use my pattern that I have to multiply by negative 2. And so my graph's going to open down. I can also see by the inequality sign, it's going to be a dashed line since there's no equal to. Then I have to figure out where to shade. So remember, there's two ways to figure this out. One way is by looking at the inequality sign, and this says y is greater than. So if I put my pen on the vertex of the parabola, greater than would mean I go up. Up puts me outside the parabola, so I'm going to shade everything outside the parabola. The other way we could do it is by testing a point. So for example, if I test 0, 0, I'm going to get 0 is greater than negative 11, which is true. So that means since 0, 0 is a solution and 0, 0 lies outside the parabola, that's why everything outside the parabola is a solution. In number 5, I have another inequality, but now this is in standard form. So I'm going to use opposite b over 2a to help me find the vertex of my parabola. So I know that the x of my vertex is 1, and then I'm going to plug that x back in to find the y. And I'm going to get negative 10. So 1, negative 10. Then I need to think about my pattern. So 1, 1, 2, 4. I'm going to be multiplying by 3, so nothing bigger than that's going to fit. So I'm going to go 1, 3. And then instead of 2, 4, I'm going to go 2, 12. It's going to go way up here. This parabola will have a solid line since the inequality symbol has a line underneath. Now again, let's figure out where to shade. This also says y is greater than. So if I put my pen on the vertex, greater than would mean I go up. Up puts me on the inside of the parabola, so I'm going to shade everything on the inside. The other option is to test a point. So if I test 0, 0, we get 0 is greater than or equal to 3 times 0 squared minus 6 times 0 minus 7. So we get 0 is greater than or equal to negative 7. Well, that's true. So since 0, 0 yields a true solution and 0, 0 is on the inside of the parabola, that is why we shade inside the parabola. The next section of the quiz was about converting between forms. So the first section says, write the following quadratic equation in vertex form. So we can do this one of two ways. We can complete the square or we can do it by finding the vertex. So if I'm going to complete the square, the first thing I'm going to do is move my c over so I can make room on the right side to make a perfect square trinomial. To figure out what goes in my blank, I use half of b squared, which would be negative 6 squared, which would be 36. So I'm going to add that to both sides. The reason I do this is because the right side should then factor into a binomial squared, which what multiplies to 36 and adds to negative 12 would be negative 6 and negative 6. So it factors into x minus 6 squared. On this left side, I'm going to combine negative 9 and 36, and I'm going to get plus 27. Now my last step is just to move the 27 over. And that will be my final answer. Number 7 is a little bit different because I'm going to complete the square, but I have an a value of 2. So before I finish completing the square, I'm going to have to factor out that a value. So before we fill the blank, factor out the 2. And then I'm going to fill the blank based on the new b value, which is now 4. So half of b squared means half of 4 squared, which would be 4. But what I add to the other side is 4 times 2, so 8. So I'm going to have y plus 2 equals 2 times, well, what multiplies to 4 and adds to 4 would be 2 and 2, so I'm going to have x plus 2 squared. And then I would minus the 2 to the other side, so my final answer would look like this. So the last one's the same idea. I'm going to have an a value of a 1/2 that I'm going to have to factor out. So it's a little trickier since we have a fraction. So now when I go to factor out this 1/2, remember when you're factoring out, you're actually dividing. So if I do 5 divided by a half, I get 10. Because when you divide by a fraction, you're multiplying by the reciprocal. So keep that in mind. So now I'm going to do half of b squared, which would be half of 10 squared, which would be 25. So I'm going to put 25 here. Then I got to do 25 times a half, so over here is actually going to go 12.5. So on this side, I'm going to have y plus, well, negative 6 plus 12.5 would be 6.5. 1/2 times, well, what multiplies to 25 and adds to 10 would be 5 and 5, so x plus 5 squared. Move that 6.5 over. So minus that 6.5 to the other side, and so my final answer will look like this. The last section was now converting to standard form. So we're going to use our polynomial operations and multiply these out. So for this first one, the first thing I need to do is write that x minus 6 twice and multiply it out. So I'm going to get x squared minus 6x minus 6x plus 36. Combine the like terms in the middle. Notice I keep parentheses around there because when I distribute the 2 in, I'm only going to distribute it to the inside part, not to the plus 7. The plus 7 will be added last because of order of operations. So this is what my final answer would look like. Make sure that you include your y equals since it's an equation. Number 10, I'm going to multiply these two binomials together, keeping that negative in front. Combine like terms. And then distribute the negative through. You could also distribute the negative through before combining like terms. Either way would be fine. And that would be our final answer.